Okay, we're gonna make a video about scientific notation. Now, before we go to this example, let's take a look at this. So here, basically, what we have is the concept and each part of the scientific notation. A is the coefficient that is a number between 1 and 10. So it's greater than or equal to 1. So it's possible that it could be 1, but needs to be less than 10. So it cannot be 10. So it's a one-digit number. 1, 1.2, 3.4, 9.8, less than 10. So that's the number here in front. Then we have 10, always is 10, the base, and n is an integer. It's a number that could be negative or positive. So let's check an example here. Let's take a look at this example and then we're gonna do some practice. So the number 43 millions to be written in scientific notation will be 4.3. Look at the point, the decimal point is here between the 4 and the 3. So I have to count 1, 2, 3, 4, 5, 6, 7. I start counting from the back. 7 to the left. So the number will be 4.3 times 10 to the 7th. Because I count 7 back, so I need to write positive exponent. In the other case, I have 0.000043. So to put the decimal point here between the 4 and the 3, right? I have to count from here to where I'm going. 1, 2, 3, 4, 5. 4.3 times 10 to the negative 5. Why negative 5? Because 4.3 is way greater than 0.00043. So once you move the decimal point to the right, you will write a negative exponent, because when you multiply this back, it will go to the original number. And when you move the decimal points to the left, the exponent will be positive, because when you multiply back, they have to go to the original number. So the 10 is the base, that always will be 10. You have the exponent, that could be either positive or negative, remember it's an integer. And you have the coefficient, that is the number that have to be greater than 1, greater than or equal to 1, and less than 10. Okay? So let's take a look at some examples here. So the exercise basically is write the correct exponent. So I have 2.5 here, so it means that the decimal points were here, right? So 1, 2, 3, 4, 5, 6, 7. Okay, so it will be 2.5 times 10 to the 7th. Then I go to the next one, 150 millions. I need the decimal here between the 1 and the 5. So I go 3, 6, 7, and 8. So 1.5 times 10 to the 8th. And I keep going. Okay, so let's do the other 3. So we have 5 millions. I need the decimal here. So 3, 6. So times 10 to the 6th. 17 billions. I need the point, the decimal between the 1 and the 7, so that will be 3, 6, 9, and 1/10. So it will be 1.7 times 10 to the 10th. 38 millions, 3.8, 3, 6, 7 times 10 to the 7. Now be careful, because if I do 38 times 10 to the 6, I mean this is correct. This one is equal to this, so they are equal, because 38 times 10 to the 6, it means basically the 6 zeros, so it is correct, they are equal. But this is not a scientific notation, because scientific notation, you need a number here, the coefficient less than 10, and 38 is greater than 10, so it cannot be a 2-digit number. It have to be 1 point something, wherever. So in this case it have to be 3.8. That's why this one is the correct scientific notation. This one is equal to this number, but is not a scientific notation. Okay, so let's do a couple of examples with negative exponent. Let's suppose we have a 0 here, 0.0 0.000000054. Okay, so how do I write that in scientific notation? So that will be equal 5.4. That's the thing I need to figure it out, where will be the decimal, and then from where will be the decimal and where it is, how many spaces do I have? 1, 2, 3, 4, 5, 6, 7. So 5.4 times 10 to the negative 7. Okay, so I have 0.0005047, for example, this number. So what do? I need the decimal over here. So 1, 2, 3, 4. So the answer will be 5.047. It doesn't matter here the decimal, how many I have, that doesn't matter. But before the decimal point, there's to be just one place. So this times 10 to the negative 4. Okay, so I hope this video helped you, and have a great day.